DEEKSHA, the concept-based digital learning. I am Pavani, lecturer in Computer Science, Telangana Social Welfare Residential Degree College for Women, Mahabubnagar. In this session, we are going to learn about templates, different types of templates and standard template library along with different types of examples along with applications. Before going to see about templates, we need to know about generic programming. Generic programming refers to the programming model where algorithms and functions are written in terms of types, that is data types, so that it works on all data types and not just for one. Here you can observe the given examples. Example 2 is for normal function, in which we specify the data type in the function definition. This normal function accepts only one argument which is of type integer. So this only works for integer type of value. In the first example, show function accepts only one argument. Here we don't know the type of argument. T represents the data type that can be determined at the time of function calling. We can call this function with different types of values. So the single show function can work for multiple data types. Here show is a function or method name. T is data type. Here data is a parameter or argument. In order to execute any function, we need to call the function. Here we are calling the function by passing the arguments. So the syntax for function calling is function name, opening parenthesis and argument list within the closed parenthesis. As this show function accepts only one argument, we have passed only one argument, that is 24. The type of this 24 is determined as integer, and in this case T in show function definition is replaced as int and value 24 will be copied to data. In the second step, we are passing 30.5 as an argument. In this case, data type is determined as float and T in show function definition will be replaced as float and value 30.5 will be copied to data, that is actual parameter. In the third step, we are passing ADITH, that is string, as an argument. In this case, data type is determined as string and T, that is template parameter, will be replaced as string and ADITH, that is ADITH, will be copied to data. So this show function is an example for generic programming as it works for different data types. The advantages of generic programming are code reusability. That is, instead of writing the same code for multiple times, we can reuse the existing code, and it avoids function overloading. That is, writing the same function multiple times but the parameters are different. And code once written can be used for multiple times and cases. Now C++ supports generic programming through the concept of templates. A C++ template is a powerful feature added to C++. It allows you to define the generic classes and generic functions and thus provide support for generic programming. As we have seen, generic programming is a technique where generic types are used as parameters in algorithms so that they can work for variety of data types. Templates can be represented in two ways. One is function templates and other one is class templates. Now we'll see function templates. Suppose if we want to write a program for adding two integer numbers, what we'll do? We just write a function as add and we'll write the logic in the function definition. In this example, add is a function name. Int is data type. A and B are function arguments or parameters, and these are also known as actual parameters. But this function is not sufficient to add two float numbers or two double numbers. So if we want to add two float numbers, again we need to write the function with float parameters in general. But this can be achieved using function templates. We can define a template for a function. We can create versions of the single add function for adding different types of values. Generic functions use the concept of function template. Generic functions define a set of operations that can be applied on various types of data. The type of data that the function will operate on depends on the type of data passed as a parameter. For example, quicksort algorithm is implemented using a generic function. It can be implemented to an array of integers or array of floats. A generic function is created by using the keyword template. The template defines what the function will do. This is the syntax of function template. Template is a keyword and then class, a t type, and then return type, function name, and parameter list. Here, except template and class t type, the syntax of function template is similar to normal function template. Here, template is a keyword which is used to represent templates. T-type is a placeholder name for a data type used by the function. It is used within the function definition. It's a only placeholder that the compiler will automatically replace with the actual data type. Here, class is a keyword that is used to specify generic type in a template declaration. RET type, that is return type, means after execution of a function, it will return a value. Normally, the execution is sequential. It will execute the program line by line. Once the program has been executed, it will return a value whose data type matches with RET type, and the function name here is an identifier. In parentheses, we will specify the list of parameters. This is an example of function template, which is written using template keyword before the function. T is a placeholder which gets replaced with data type. This add function accepts two parameters. This function is meant to add two numbers, and the result will be stored in result variable and value will be returned after function execution. Here we are calling the add function from the main method by providing arguments. Here we took two integers I and j, and these arguments are passed to add function. In the next line we are calling add function with two float numbers. Whenever we call a function, control will go back to the function definition, and after execution it will return to main method. When we call a template function, compiler will automatically add data type and t will be replaced by that data type. When we call a method add I, j, then compiler will automatically add int data type in angular braces, which is same for float. In this example, we have created function template which can perform addition operation on any type. Either it can be integer or float or double. Now we'll see about function templates with multiple parameters. In the previous example, we have passed two arguments which are of same data type. We can also pass multiple arguments of different types for the single function. We can use more than one generic type in the template function by passing a comma to separate the list. This is the syntax for function template with multiple parameters. Here we took two placeholders represented with T1 and T2. These T1 and T2 are two different data types. We can have more than two different data types as well. This is an example of function template with multiple parameters. Here fun is a function template as it is preceded with template keyword, and this function accepts two arguments, and these two are of different data types. The purpose of this function is it is just displaying two values a and b. This single function can work for multiple data types. That means it can display one integer number, one float, or one float, one int, or one character, one integer, and so on. This is the main method. We are calling fun method by passing two arguments. One is 15 and other one is 12.3. Here 15 is of type integer and 12.3 is of type float. So T1 will be replaced with int and T2 will be replaced with float. Here 15 is copied to A and 12.3 is copied to B. Now the function fun displays these A and B values. This single function can work for any two different data types instead of creating a new method. Here, class templates can also be defined similar to function templates. When a class uses the concept of template, then the class is known as generic class or class template. This is the syntax of class template. Class template can be written using template keyword along with class name, and T-type here is a placeholder name which will be determined when the class is instantiated or when the object is created. We can define more than one generic data type using a comma separated list. The T-type can be used inside the class body. Now we'll see the syntax for creating an object or an instance of a class. Class name and type and object name, where class underscore name is the name of the class. Type is the type of the data that the class is operating on, and OB is a name of an object, or OB is the name of the object or reference. Now let's see an example program for class template. We are creating a class template for class A. Here T is a placeholder or data type. Class A has two variables, num1 and num2 of T type. Here we don't know what type of data it is. We have defined user-defined function add, and we are displaying these values using cout, which is an object. In order to call add method defined in class A, we need to create an object in main method. So this is a main method. So we are creating an object for A as A and specify the type space object name. Here D is an object name or D is a reference name. We are calling add method using member access operator, that is dot operator. When we use d.add, it will call add method. Now we'll see class template with multiple parameters. Similar to function templates, a class templates can also have multiple parameters. This is the syntax for class template with multiple parameters. Template is a keyword, and in angular brackets we specify how many different data types we want. Then class keyword and class name. Here T1 and T2 are placeholders which gets replaced with data types that are specified at the time of object creation. Let's see a simple example when a class template contains two generic data types. Here A, capital A is a class name. Generally we write classes with capital letters, or if we have a word then we write class name, the starting letter should be in capital. And T1 and T2 are template parameters. For the previous class template, we can create an object like this. Class name A in angular brackets, specify in float space object name. T1 will be replaced with in and T2 will be replaced with float. Now we'll see about non-type template arguments. The template can contain multiple arguments, and we can also use the non-type arguments in addition to the type T arguments. We can also use other types of arguments such as strings, function names, constant expressions, and built-in types. Let's see the following example. In this case, the non-type template argument is size, and therefore the template supplies the size of the array as an argument. T is determined at the time of object creation. Here, arguments are specified when the objects of a class are created. For the previous example, class template, we can create an object by providing data type and value. Here, data type is for template parameter and value is for non-template argument. Here 15, 10, 4 are non-template arguments, and in float character are template arguments. T1, T2, T3 are object names or reference names. Now we'll see about standard template library. C++ standard template library is a powerful set of C++ template classes to provide general purpose classes and functions with templates. And this implements many popular and commonly used algorithms and data structures like vectors, lists, queues, and stacks. As a programmer, one has to make sure to store data in such a way that the retrieval and manipulations become easy to resolve, and this is called as a standard template library. Many innovators who intend to bring a massive change in various tech fields are working on designing new algorithms and implementations respectively. And storing data becomes a tough task. Eventually, that makes room for great importance about standard template library in C++ that resolves their queries to a larger extent. Now we'll see the components of standard template library. The components are divided into three: algorithms, containers, iterators, and functors. Algorithms act on container data with some predefined functions wherein data gets changed for better results and provide a smooth way for further manipulation. Suppose there are some points and one has to arrange them in increasing order of their values. So they applies the strategy to place the points in a row and then they swap their positions to sort them in increasing order. So the strategy or a technique that has been used is said to be as an algorithm which enables them to sort the coin. Algorithms are divided into two types. One is non-manipulative algorithms and the other one is manipulative algorithms. Some of the examples are sort and arrays. So sort comes under the category of non-manipulative algorithm. It arranges the data in ascending order or an increasing order. And arrays function, it detects the elements whose location is sent as parameter and resizes the vector. Here now we'll see about containers. So containers are used to manage collection of objects of a certain kind. There are several different types of containers like DQ, list, vector, and map, so on. It's like people standing in the row with the power in the hands of the executor to manipulate the row in his or her choice and can add more people in the row in any fashion. Some of the examples of container are vector list. So vector is a dynamic array that permits the insertion and deletion of data from the end of the vector. And the list allows non-contiguous memory allocation, just as in linked list, insertion and deletion can be done from anywhere in the list. Now we'll see about iterators. So iterators are the smart pointers that point to the data in the container like pointers do. But it will help in traversing over complex data structure which pointers cannot do efficiently. It's similar to a blinking text cursor in editor. While typing, they initially appear at the starting, and when we type, it automatically shifts itself to the end of the content. But we can take that cursor to any of the text area. Here we'll see about some of the types of iterators. So input iterator. All algorithms are sequential or linear traversing where every element is traversed only once. And output iterator. They are just like input iterators, but they only assign the elements. And now we'll see about functors. So functors are function objects that are passed as arguments and point to those functions that are to be executed. So functors are mostly used to handle events. Now these are the points to remember. C++ supports a powerful feature known as template to implement the concept of generic programming. A template allows us to create a family of classes or family of functions to handle different data types. Template classes and functions eliminate the code duplication of different data types and thus makes the development easier and faster. Multiple parameters can be used in both class and function templates. Template function can also be overloaded. And we can also use non-type arguments such as built-in or derived data types as template arguments. And standard template library. As a programmer, one should be well versed in standard template library to implement the new algorithms. It eliminates complex looping structures and helps in resolving the extreme real-world problems for world ease. Let's recap the concepts we have learned in this session. We have seen generic programming, which works for all data types. If we understand this concept, it will be easy for us to understand templates in C++. When we go back to C language, we have functions, that is, it works for it has set of instructions and it will do some task. But we have other concept, function overloading, in which we just give the function name as same, but the parameters are different. So that function overloading creates lots of duplications. So that disadvantage is also overcome in this generic programming. So it will be easy for us to understand templates if we understand generic programming. Then we have seen templates in which generic data types are passed as arguments. So C++ achieves generic programming through this templates concept. Then we have seen different types of templates. Those are function templates and class templates. There is not much difference between normal functions and function templates, except that we are defining function templates by using template keyword and class and by specifying generic data type. And then we have seen class templates. So this class template, in this class template, we are giving data type, that is generic data type in the class definition. And then we have also seen function templates with multiple parameters and class templates with multiple parameters, so that these can work for different types of data. Here, multiple parameters means multiple different types of parameters. For example, in a function, if we give add t1, t2, then t1 can be one data type and t2 can be other data type. Example, if t1 is integer, then t2 might be float, or if t1 is float, t2 might be integer. Then we have seen non-template arguments. Those are passed as arguments along with templates. As we have seen in an example, like when we are defining an array, we have just given a data type and then normal value. Here, data type represents a template argument and normal value represents a non-template argument. So we have also seen this non-template arguments, how we are passing these non-template arguments along with templates. And then we have seen about standard template library, and this standard template library is a collection of classes and functions. That is, collection of template classes and template functions. And then we have seen about containers, iterators, algorithms and functors, and these all are used for easy access and manipulation of data. And we have seen all these concepts with different examples and with different types of data we have passed, and we have seen how the programs have been executed. Thank you.